We are going to find the integral of y plus 10 over 5y minus y squared dy for all values of y in the domain of the function using partial fractions. This video is probably going to be the longest one in the series because we are going to go back and revisit an Algebra 2 concept. Before we do that, let's figure out, why do I have to use partial fractions? Why can't I just use u substitution? So if I were to use u substitution, I would say my denominator, 5y minus y squared, is my u. That would make my du 5 minus 2y. Unfortunately, I do not have 5 minus 2y here, and I don't have any variation of 5 minus 2y there, meaning I don't have a factor of it. And that's why u substitution doesn't work without first doing a little bit of manipulating. So u substitution isn't going to work. So we're going to try partial fractions. And partial fractions really is a method of breaking this fraction back into two fractions that were added together. So we have y plus 10 over 5y minus y squared. And that is equivalent to some integral of a over something plus b over something. And these somethings are the factors that created this denominator. So that factors into y times 5 minus y. That is what goes under a and b. So y and 5 minus y. And of course, we still have a dy here. So what we know is that when we multiply this 5 minus y to this side, and when we multiply this y to this side, we should get y plus 10, meaning our y component should equal 1, and our constant component should equal 10. So let's go ahead and do that. Let's say that I multiplied this 5 minus y by a. So this is just a side note. So we have 5 minus y times a. And then we have plus, we're going to multiply this y by b. We'll distribute in this a. And so we have 5a minus ay plus by. What we know is that this piece right here needs to add to y, just y. So this piece right here needs to add to y, or it needs to add to 1. And we know that this piece right here needs to be 10. It needs to be 10. Well, that's easy. That means a has to be 2. A has to be 2 because 5 times 2 is 10. So a equals 2. And then that helps us figure this out. If a is 2, then I have negative 2y plus by. B has to be 3. B has to be 3 because that's the only way. Negative 2 plus 3 equals 1y. So B is 3. And of course, there's other ways to do that. You could have set up a system of equations. You could have said negative ay plus by equals y. And that being said, 5a has to equal 10. You could have set it up that way. And if you set it up that way, then you could figure out what a and b are. I did it a little bit more intuitively. And so doing it intuitively, I was able to figure out that a was 2. Now we're ready to integrate. 2 over y plus 3 over 5 minus y dy. Well, look at this. I could rewrite that with the 2 out front, and I'd have 1 over y dy. I could rewrite this with the 3 out front, and I would have 1 over 5 minus y dy. And then I could use logs, because the integral of 1 over u du equals ln of u plus c. Well, If my u is y, my du is 1. So this becomes 2 times ln of y. This one's a little bit trickier because my u is going to be 5 minus y, making my du negative 1. So I would have to add a negative here, and in turn add a negative here. So I'd have minus 3 ln of u, which is 5 minus y, plus c. And I'm done. So the hardest part of this was not the integration piece of it. As soon as you break these fractions up, the integrating piece of it was a piece of cake because we just used this integral of 1 over u du as ln of u plus c. The challenging part was actually the algebra 2 part, where you're taking this fraction and you're breaking it back up into two fractions that are equivalent.